Hi guys, let us see linear search. Linear search means search for a key in a given list of numbers by comparing with the first element to last element in the list, which is easy to implement because we start with the first element, compare with the key value. If they are not equal, then we move to the second element. If they are not equal, we move to the third element, and so on. We go up to the last element. Suppose if we find the key value in the list at any position, then we stop the search process. Let us see the algorithm for the linear search. So here, the linear search, what is the input we are going to give it? An array of values and n, that is n value we are going to give it as input, and the key is the value which you want to search in the list. Okay, then we start with the I is equal to 1 and f is equal to 0. The I is used for counting as a counter, and f is used as a switch. Okay, so initially I make it as f is equal to 0 while I less than or equal to n. That means we repeat the process. So we start with the first element and compare whether it is equal to key. If they are equal, then I make the variable f is equal to 1, then break. Break means you come out of the loop. So when you come out of the loop, if f is equal to 1, print element found at index I. Suppose if the condition becomes false here, I is equal to I plus 1, that means second. So it will go to the second element. So again, the checking process will take place here. If they are equal, it will come out. If they are not equal, then I is equal to I plus 1, that is it goes to the third position. Then it will compare with the third value. If they are equal, it will come out. If they are not equal, it will go to the fourth position. So this will be repeatedly executed until the I value reaches n. Okay. So when you come out of the loop, if f is equal to 1, that means we found the element at index I. Suppose if initially we made f is equal to 0. Suppose if the key value is not available in the list, this condition will never become true. So that means f is 0 only. So if f is 0 means we print an element not found in the list. This is the algorithm for linear search. So we calculate the time complexity of the linear search. So what do you mean by time complexity? Time complexity means time taken to execute an algorithm. So if to be strictly speaking, the time is to be calculated by executing an algorithm. That means through experimental setup only we can calculate the exact time. But what is a drawback in calculating time through experimental setup is computer system configurations may be different, and hardware configuration, software, what the software we use, it operating system and compiler, so all these things may be different. So when you have a different setup, and the algorithm time calculation may not be accurate. Suppose you run the algorithm in a particular system with a setup, for example, hardware and software configuration, and when you go to the another system, the calculation will be different. So to avoid that drawback, so we calculate the time complexity in terms of number of steps required for an algorithm. So here, for this statement will never be executed, so I take it as 0. I is equal to 1, it will be executed one time, and f is equal to 0, it will be executed one time. This statement, while I less than or equal to n, will be executed n plus 1 time, because when I crosses the value n only, it will come out of the loop. That is, it will reach n plus 1 also. So this statement, if a of I is equal to key, every time we will check the value, so it will be executed n time. But this f is equal to 1 and break will be executed only 1. That is, when condition becomes true only, this statement will be executed. So that is executed for only one time. And I is equal to I plus 1 will be executed n times. And this whole thing will be executed two steps. How? this statement is executed only once. And if the condition becomes true, this will be executed. False means this will be executed. So 1 plus 1, 2. So if you add all these things, you will get a 3n plus 6. That is the total number of steps for the linear search. When n tends to infinity, the value of coefficient 3 and 6 become negligible, and so it may be represented as a order of n. In the previous slide, we have seen that the total number of steps is 3n plus 6. In 3n plus 6, when n become a larger value, the 3 and 6 will become very negligible. So we will represent it as a order of n. So the time complexity of linear search is order of n. Then what is best case time complexity means? Best case means minimum number of steps required for the particular algorithm based on the input. For example, we are searching for a key value in the linear search with a particular list of numbers. Suppose if we found the key value in the first place itself, so there will be only one comparison will take place. That is what best case. What is worst case means maximum number of steps required for the algorithm. So here the element appears at the last place, or the element is not there in the list. That is key value appears in the as the last element, or the key value is not available in the list means n comparisons will take place. That is why we call it as worst case time complexity is order of n. Average case time complexity means average number of steps. So the key value may be available in first place, second place, third place, fourth place, fifth place, and so on, nth place. So how many times we are trying this attempt? N times. So if you divide by 1 plus 2 plus 3 plus 4 plus and so on n by n, the numerator, there is a formula n into n plus 1 by 2 for the sum of the series of 1 plus 2 plus and so on n, and divided by n. So what will happen? This will become n plus 1 by 2. So that I can, as we already discussed, when n tends to infinity, we can express it in order of n. So average case time complexity of linear search is also order of n.